Right, hello there ladies and gents, welcome to another repair video. Today we're going to be working on this PlayStation 4 which has been sent in, and this console has been sent in because it has no display. So if we take a look at the ticket, we can see that it's coming for PS4 original HDMI IC chip / HDMI filter replacement, and I thought I'd do a video on this because I haven't touched on this topic for quite a while. And every time I don't do a video on this particular issue, it turns out to be something different to what I have covered on the channel before. So I thought to do a video, do a little update and see if we've got a different issue to the ones that I've done previously. So you'll notice that the light is orange, that's because this is take number 2. I keep getting disturbed every time I go to record the video, so it's in standby at the moment. But I do have the HDMI cable plugged in and the power lead, and I'm going to be using my typical camera app to test it for display. So let's turn it on and we'll just see what's happening. And if we go to my camera app there, you'll see we've got a blue light at the moment. It will go white, I have already checked that, but you'll see that the screen is blank. We've got no display logo, we've got no output at all for video. And one thing I haven't tried yet is to try and boot it into safe mode, so I will try that as well once I show you that it's not working when it loads up to the actual dashboard. So there we go, as you can see we've got a white light there and that is not displaying anything on the screen whatsoever. So that should be showing in my camera app on here now, and it's not. So let's shut it down and I'll show it you in safe mode and see if we can get it to boot into safe mode. Okay. So press and hold the power button or the touch button. Wait for that second beep. There we go. Let's see if it wants to load in safe mode. Absolutely nothing. So no safe mode, no low resolution mode, and no standard 1080p mode. Okay, right, so let's get this thing taken apart then. So one thing I have noticed about this is the fact that it's got 2 gold warranty stickers on, and that only means one thing. Because this has come from Console Repair London, the company that sends me quite a lot of consoles, they always put gold warranty stickers on once they've done a job. So this has been in for repair before. I'm not 100% sure on what it would have gone in for. However, the HDMI port looks pretty mint, and it looks to me like it's a V2 port. Obviously I haven't been inside this yet, but it looks to me like a V2 port, which means the HDMI port has probably been changed at some point in the past. So what I'm going to do, I mean, I know you can buy those warranty stickers, but because Console Repair London uses those warranty stickers, I'm going to say that they've probably worked on this before. So it's probably had a HDMI port or something at some point. As you can see, I'm breaking that seal there. I haven't actually been inside this yet. This isn't a customer which I've worked on the console for before. So it's going to be quite interesting to see what's been done inside here. It does look incredibly clean. So I'm going to say it's probably been in for a HDMI port and had a service at the same time, most likely. And from what I can tell, this is going to be the SAB001 model. That's because it's got this black screw here. So I'm going to say this is the SAB001 model. And yep, as I suspected, it is fairly clean inside. So let's just get this thing taken apart then. Okie doke. Okay, all the thermal pads are there, that's good. None missing. So let's just get the motherboard out. Let's pop those thermal pads back. This is quite recent. This thermal paste is still very wet, so this is quite recent. Alright, so good news is I don't need to do anything to that. So that's going to save me a bit of time. Okay. Right, so the first thing that I want to do then is I want to do some tests on the components around the HDMI port. And I have noticed that this is a V2 port, which means that it has had a replacement port in the past. The V1 ports have the pins exposed on the back, whereas the V2 ports have solid plastic on the back, which prevents those pins from being pushed out. So as you can see there, it does have a V2 port. So it's definitely had a replacement HDMI port. So what I'm going to do then is I'm just going to do some quick tests. So I'll pop under the microscope and I'll show you what we can do to figure out what's going on. Okay, so underneath the microscope then we can see that we've got the HDMI port here, and this is obviously where the HDMI signal goes out to the TV or monitor. So the first thing I'm going to do is I'm going to check the pins and make sure that they're all soldered correctly. And usually, from experience, when Console Repair London has done the HDMI port, it's generally a fairly good job. And as you can see, it's really clean as well. So they usually do a fairly good job in terms of HDMI ports. Okay, and those pins are absolutely fine. Not a problem with any of those. I do know that the way that they put the ports on is to use a hot air rework station, exactly the same model that I've got, the HDIR Pro SC, and they will heat up the port. They'll take the old port off and then they'll just drop the new one straight on, and it solders straight on. So they do it pretty much like a pick and place machine would, which is why they get such consistent results with the HDMI ports. And like I said, they do a good job about it. So as you can see, he cleaned it up really well and he's done a fairly good job. So what I'm going to do now then, because those are testing fine, I'm going to pop the multimeter into diode mode, and I'm going to test the 2 protection diodes here and then a couple of diodes just below as well. So we should get a reading one way and we shouldn't get a reading the other way. So with the black probe on the input and the red probe on ground, we'll get 0.625 in diode mode, which is absolutely fine. So let's test this one. 0.626, perfect. 0.641, perfect. And then this one we need to flip the lead around because the diode is the opposite way. 0.704, perfect. Those are all reading exactly as they should. Let's flip the leads back round and check this one here. 0.712, perfect. Okay, so let's flip the leads around now then, and let's see if we get anything this side. We get open line for that one, which is fine. Open line for that one, that's fine. Open line for that one, that's fine. Open line that side, that's fine. And if we flip the leads around, so as the black probe is on ground, and we get open line on that one, that's absolutely fine. So the entire purpose of a diode is to only allow current to flow one way. So we always have to get open line on one side, and then we have to get a decent enough reading. So say for example 0.2 volts, depending on the board, 0.2 volts to 0.7 volts, 0.8 volts, something like that. It all depends on the board. All boards are going to be different, but if you get something around the 0.1 volts or 0.005 volts or something like that, then you've usually got a short to ground. So that's reading absolutely fine. Next, what I want to check is for shorts to ground on the capacitors around here. So these big caps here, I'm going to check for shorts to ground. And I'm going to do that by going into continuity mode. Continuity mode is the mode that's going to beep when we complete the circuit. So I'm going to pop one probe on ground. Any probe will do, it doesn't matter which. And then if I probe anywhere else on the board, so say for example this port here, you'll see that we've got continuity. So I'm going to check these caps on the input sides and just see if we've got any shorts to ground. So the input side for these two here is here, and we get no beep. This one is here, we get no beep. This one is here, we get no beep. No beep. And no beep. And then finally on the protection fuse, we get no beep. Okay, so they're all testing fine. Next thing I'm going to check is this fuse here. Sometimes this fuse here can blow, and this is actually a resettable fuse. And the only place I've found to buy these so far is on AliExpress. I will leave a link in the description to these, but the only place I've found to buy these is on AliExpress. So let's test these. I usually just use a donor board. That protection fuse is absolutely fine. So everything on this side of the board appears to be testing absolutely fine. We do have some more of the circuit on the other side of the board. So let's flip the board around and let's have a look. Okay, and taking a look at the other side of the board then, we can see that we've got the HDMI port. So the HDMI port is just here. And then, excusing the reflection, we've got a EMI shield here. So this is a shield which protects the EMI filters and also the HDMI encoder. So the HDMI encoder on this one is the MN86471A. It's a Panasonic HDMI encoder IC, and these are fairly expensive chips, so it's a bit of a pain in the backside when these die, because it does get quite costly for the customer. But we're gonna remove this shield. I'll go back to the normal camera. We'll remove this shield and we'll test the components under here. Okay, so as we can see, we've got the shield here. And like I said, this needs to come off so as we can test the rest of the components. So what I'm going to do is just use some hot air, and I'm going to desolder this shield because it's actually soldered on in several points. So it's soldered on here. It's soldered just here at the side. There's another solder point here. There's another solder point here at the top. And there's another long solder point on the left hand side. So we need to remove all of those solder joints, or rather heat up those solder joints to remove it. And then we can test the components underneath. So I'm going to start with this one just here. So what I like to do with these is use my hot air and put some pressure on the actual EMI shield itself. So I'll put my tweezers underneath. It does fit in the gap, and then I'll pull up slightly, not too much, but I'll pull up with a little bit of upward pressure. And the reason for that is because that's going to allow us to remove each joint and keep it off while we're removing the other joints. So you'll see that in a moment. I will zoom in. And if we use some hot air now, just there. You see that one's just popped up. And then I'm going to push them into it a little bit further. Keep some more upward pressure. So just enough so as it's kind of pushing back at you and giving you some resistance. Not too much, we don't want to tear the ground plane. And there you go, you see that pop up? So now I'm going to move my tweezers over to this side and do the same again. And that just popped up again. And then I'm going to grab the tweezers, or grab the shield with the tweezers, and start to gently pull up. This is the side we need to be careful of because it's got a big ground plane with a lot of wires, and we don't want to end up tearing that. So we're going to just allow it to remove itself gently. So that top point has just come off. And then if we heat up this area here, we'll notice that it's going to slowly lift itself up. And it's going to slowly put itself away. There we go. And that is removed. Perfectly safe. And no damage to the board itself. So let's go back under the microscope now. And we'll take another look and see what's happening with this. As we can see here, we've got several components here. If we zoom in, we can see that we've got a few components here, and most of these are capacitors, as you can see, indicated by the fact that they are connected to ground on one side. And then we've got a filter as well, so we're going to go into continuity mode and we're going to check this filter for shorts. That's not short, which means that none of these caps are. And you'll notice that the first few pins on this chip are shorted together. So if we take a look here, you'll see that pin 1 and 3 are shorted together. That's perfectly normal. But this side is not shorted. This side appears absolutely fine. That cap doesn't appear to be shorted there either. So that's perfectly fine. So let's move down to this side then, where we've got exactly the same kind of setup. And I'm going to pop one probe on ground again and check these once again on this side. And they're absolutely fine as well. So those are all fine. So next I'm going to check the EMI filters. And the EMI filters are essentially just a coil of wire, and they're designed to reduce electromagnetic interference, hence the name EMI, before it goes out to the HDMI port. So 8 of the pins on the HDMI port are connected to this here, and then this is connected to the chip, and then the chip is connected to the GPU. So what we're going to do is we're going to check these. We should have continuity from the top to the bottom. There are 2 filters on each of these, as you can see from these traces here. So there are 2 filters on each of these components, and we should have continuity from the top to the bottom, but we shouldn't have continuity from the left to the right. So we're going to check these and just see if we've got any shorts or any abnormalities. And if we do have a short where it's short from left to right, then it could be the chip, or it could be the chip, or it could be the filter. If we've got no continuity from the top to the bottom, that is definitely the filter that's at fault. And if we short it to ground, then the only realistic path to ground is through the chip itself, because there's no path to ground through the HDMI port as long as we've got no solder bridges. And given how this port was soldered on, I'm going to say that the chances are it's got no solder bridges. So let's test these components then. So we'll test from top to bottom first. Good. And then we'll say left to right. Good. Good. And you'll notice that I'm keeping one probe on one of the filters, and then I'm testing the one next to it to see if we get a beep. And then I move over to that next filter, and if we get a beep this side but we don't get a beep there, then we've got no short. Okay. Right, so all of those filters test out okay. So let's just check and make sure we don't have a short to ground on any of these filter pins. And we do not. So everything else is testing okay. The only other thing that this can be is going to be the HDMI encoder. So we're going to get that changed, and hopefully it's going to fix the white light of death issue. So there are several ways that we can actually change this chip, and the first of which being just to use hot air. And we could just use hot air, remove the chip, and then just drop a new one on top. What I like to do is, instead of just using hot air as you normally would, I like to replace the solder with leaded solder first. So we start by adding some flux. There we go. And then I'm going to take the soldering iron, and I'm going to replace all of the solder on here with leaded solder. You can also use low melt solder, but it just makes a little bit more of a mess. And the simplest way to do it is just to drag across all of the pins. And this probably isn't the correct tip to be using for this particular job, but never mind. So you'll notice that the solder is going to follow the heat, and that's because solder loves heat. This is what we call the drag soldering method, albeit I'm not using the correct tip here, but this is what's called the drag soldering method, and it's probably by far the fastest way to solder one of these particular chips. There we go. Some nice big blobs of solder there on that chip. So we're going to get this chip removed now using hot air. So while I've got your attention, if you are new around here, don't forget to like the video and subscribe to the channel for more repair videos. And there we go, so that chip is now removed. I'm going to pop that to one side. One rule I live by is never throw the original chip until we know 100% that that is the cause. Because number one, we could put that chip back on if it wasn't the cause. And number two, if we can't fix it, we'd put the chip back on before we send it back to the customer with no charge. So obviously we don't want to leave a working chip on there if we are not going to get paid for the job. So let's go ahead and clean up the solder pads on this motherboard. And the way I'm going to do that is by wicking away at them. So for those of you that are interested, I use Goot Wick, and it's cheap and cheerful, and it definitely does the job. And the flux I'm using is Kingbo RMA 218 as well. Okay, so let's clean up the board then. So I'm going to use some isopropyl alcohol and a cotton swab. Okay, so now the chip's now the board's nice and clean, I can get it ready and drop another port on it. So I'm going to change my tip to a more suitable tip for drag soldering. And I'm going to be using a knife tip. Okay, and I've got myself a chip there. So the chip that I'm using there is actually a donor chip. It's come off a donor board because these are getting rather difficult to come by right now. So I may not be successful the first time. I might need to find a chip that actually works. But hopefully it works first time and we don't have to change it again. So what I'm going to do is I'm going to line up the chip with the board so as it's pretty much dead in line. And what I'm going to do now is I'm going to hold that chip in place with my finger. I'm going to add some flux to the one side. And what I want to do is just tack the one side of this chip down so as I can solder the rest of the sides. So I'm going to pre-apply some solder onto my tip, all while holding the chip with my other hand. Just make 100% sure that that's in position. And that chip is now tacked into place. So now I can carry on soldering the other sides, and then I'll come back to that side and clean it up. The drag soldering method doesn't seem to want to work, so I'll have to solder them all manually. The pins might be slightly out of line because it's come from a donor board, but that's fine. So what I'll do then is I'll just change tips to a suitable tip to solder each pin individually, and I'll not use the drag method on this one. For some reason, drag soldering seems to be working better on this particular tip. Okay, I'm going to swap tips. I know I keep changing tips, but I can't seem to get the heat transfer off that one. It's not really the best ideal tip. So I'll change to a fatter version of that. Okay, let's just change the flux as well, so as we can put some fresh flux down. So I'm going to use some hot air and just melt this flux that's decided to start gunking up. Okay, let's just dry that off. There we go. This tip should be much better. Okay, so I'm going to clean off the excess once I'm done. Okay, let's start to wick some of this away now then. Okay, so I'm going to clean up again and then I'm going to run over it with the soldering iron once more. Right, okay, so my ring light just decided to shut down because it was too hot, so let's carry on cleaning this. So I'm going to heat it up now because the flux that's on here is going to have gone a little bit gunky. So I'll just heat it up, that will allow us to remove it easier. Okay. Just dry that off. And now I'm just going to touch up these pins, make sure we've got no bridges, and then we'll be good to test. I know we've got bridges right now, but we can fix them all. Okay. Okay, let's focus on this side. Okay, so I've noticed that one of the pins are slightly out of shape, so that's going to cause issues with solder bridges, so let me just straighten that up. Okay, so let's clean up again then, and then we'll see what this looks like. Might have to do a little bit of reshaping on some of the pins. Like I said, this has come from a donor board, so we're going to need to make sure that all the pins are straight. Okay, so I'm going to zoom in now and just check each pin individually. And I can already see a solder bridge Okay, so I can see the reason that it keeps bridging. So basically what I need to do then is just be able to push this so as it's back in line with its pad. There we go. Right, so I'll check that again. And those pins do appear to be good now. So what I'll do is I'll just give them all a quick nudge test, and then we'll focus on the other ones. Okay, all of those pins are solid. So one thing I'll do before I go ahead and focus on the rest of them is just make sure in continuity mode that none of the pins are bridged together where they shouldn't be. Just in case there's something I can't actually see, because you only really get one shot on these chips before it ends up killing the chip. So I'll just check each pin individually. And those two I believe are meant to be bridged together. I will double check it on another board. Okay, let's check these ones. Good. And let's check this side. Good. So none of them pins are bridged together where they shouldn't be. As far as I'm aware, these two pins here are meant to be bridged. So I'll double check that on another board off camera. But as far as I'm aware, they're meant to be bridged. So let's just take a look at a donor board. Okay, and it's these two pins just here. And as you can hear, those two are meant to be bridged, and you can visibly see them where the wires join together. So that's absolutely fine. So what I'm going to do is I'm going to give the other three sides a nudge test, make sure that they're all soldered correctly, and then I can get to testing this thing. Perfect. Every pin is soldered. Let's just double check this end once more. And I'm almost sure I can see a bridge there. I'm not 100%. And apparently not. So that must just be a little bit of crap underneath the pins. Maybe a bit of burnt flux or something. Okay. So I'll carry on giving these a nudge test then. Absolutely fine. Alright. Okay, so just about ready to test now. So let's just pop this in here. I'm not going to change the thermal paste yet. I'll do that once we've confirmed it working. Reason for that is because if I need to take it off again, then I've got to change the thermal paste again. And I am using a donor chip, so the chances are, well, it's got a chance that it's not going to work, being as though I'm using a donor chip, and also because I need to solder this back on once we've finished as well. So for that reason, I don't change the thermal paste until the last minute. So all I'll do is just screw this down, screw the put the power supply in and the hard drive, and that's pretty much it for testing. And let's hope that the donor chip I've used is good. Let's get the hard drive and turn it on. And there we go, we get safe mode straight away. So I'm going to connect up a controller now, and what I'll do is I'll load it into the dashboard, I'll test everything out, make sure everything's working absolutely fine, and then if it is, I can clean up the APU, put some fresh thermal paste on, solder that shield back on, and then call it done. So to connect up a controller. My controller wants to play up again. For some reason it never syncs first time. Don't know why. There we go, now it's synced. Right, so let's select change resolution then. And that will set it to 640 by 480 when we boot into the dashboard. And then we can go through the resolution and make sure that it loads up in 1080p. Okay, just waiting for this to load into the dashboard. So it's just going to reboot again. Just needed to check the system storage status before it does. And there's the PlayStation logo. So I can clearly see by the image quality that this is in 640 by 480, but I'm expecting that anyway because I've reset the resolution. So let's just set this to 1080p. And it's not loading in 1080p. Right, that could be a handshake thing. So let me just reboot the console quick. Could well be a handshake thing. Right, and it's not loading in 1080p. Oh, hang on. So I might need to change this chip again. I will confirm it by testing it on a proper TV, because one thing I've noticed about my computer is that sometimes it doesn't like to work properly on a PS4 on my capture card. I'm not sure why, but it just doesn't seem to handle it very well sometimes. So I'll go and test it on a TV, I think, and I'll just get some footage on my phone. One thing I can do is just test it on the monitor without the HDMI splitter and things connected up. So I think I'll do that. Right, okay, so let me just adjust the camera a second. And as you can see, it is working on 1080p. when it's connected directly to the monitor. So let's just connect it all up. So we've got audio. Just turn that down a little bit. And then I'm going to go to network. Let's set up the network. So I apologise about autofocus there being a little bit strange. There is a subliminal message in that Wi-Fi password. There's a subliminal message here as well. There we go. Internet is working. So let's go to, whoops, we don't want to do that. Resolution, 480p, working fine. 720p, working fine. 1080p, working fine. That is what I'm talking about. Okay. Let's do a final check. What I'm going to do is just check a PS4 disc. So I'm going to pop in FIFA 16. We get the disc loading icon there. And there's FIFA 16 loading up absolutely fine. So that means that the console appears to be working perfectly fine. Let's just update later and make sure that it actually loads the disc. Again, I apologise about the autofocus messing up a little bit there. It can't seem to focus properly. So we've got wireless sync as well, as you can see. And my games are all dirty, but never mind. Please don't tell me to clean the monitor. I'm not going to do it. For some reason it's not ejecting a disc. Never mind, it was just trying to load it. Ignore that. Okay, so it's ejecting the disc fine. So yeah, that's all the tests passed. So let's just give it a final clean up, put it back together, and we'll call this job done. So I'm going to shut it down properly. And then I'll switch back to the PC and I'll get it all hooked up properly. Okay, so like I said then, we need to just put this shield back on. So I need to solder the shield back on, and I also need to put some fresh thermal paste on. So we'll do that. We'll give it a clean, make sure it's all ready to go and that it's not going to overheat. And then we can call this job done. Okay. So the reason that it wasn't working on the capture card is because the capture card doesn't appear to like, even though it works in 4K, it doesn't appear to like the handshake changing between resolutions on a PlayStation 4. I'm not sure why. I mean, it's a £7 capture card. It's not exactly an Elgato. Although I will probably buy an Elgato one day. But at the moment, it's just what I'm dealing with. So I always generally test these on a TV as well. So when I take this ready to be packaged back up, ready to be shipped back out, I will test it on a TV as well, before it actually goes out, and make sure it loads on a TV, make sure it loads in 1080p on a TV, and then we'll be good to go. Right, so what I'm going to do then is I'm just going to take the soldering iron and just run a bit of solder across this just to put the shield back on. It doesn't have to be soldered exactly how it was, as long as it's there and as long as it's doing its job. So we'll run the soldering iron across it and just make sure that it's protecting it from any kind of interference. So I'll add some flux down the one side. Let's pre-tin the soldering iron. I'm not going to touch this with my hands because it gets incredibly hot incredibly quick. And you probably shouldn't touch it with something magnetic either. But never mind. Let's just do it this way. That's already starting to burn my hands. Okay, so I'll use hot air to solder it back into place then. So I'll just replace the solder that's on here with some leaded solder. On that shield. And then I'm going to take off my nozzle and just solder it down. There we go. So that shield's back on. Always make sure you put that shield back on. Okay, let's just get rid of the thermal paste, even though this is pretty much brand new thermal paste. There we go. Let's get some fresh MX4. The perfect amount, of course. And then I'm just going to clean the paste off here as well. There we go. Beautiful. Right, so the other two missing pads are on the RAM chips themselves. So we haven't got any missing thermal pads there. Okay. And there we can reassemble. Okay, so I'm going to replace that because it did snap off while it was in my care. So just replace that little earthing clip there, that little grounding clip. It's not absolutely necessary, but you know, I've got loads of them, to be honest. And it was in my care when it snapped, even though it was very weak. I only lifted it up, but I'll just replace it anyway, just for the sake of it. Okay. So I'm just going to get the rest of this screwed in now. Okie dokie, and that, ladies and gents, is pretty much that. So I don't need to do any more testing. I will do another test in the house on a normal TV, just to make sure it all works properly. But let's just summarise on this one then. So this one was originally sent because it had a white light of death, and the description, as we can see, said HDMI IC chip / filter replacement. And what we did was we went from the back of the circuit, so at the HDMI end, right the way back to the first component in the line that will fail, or the first component that will typically fail, and we determined that the issue was down to the MN86471A. That's the HDMI encoder IC for the PS4 original. When the PS4 1200 series came out, the SAC001 motherboard, they switched to the MN864729, which is a QFN style chip. But for these ones, it's the 71A. It's a chip by Panasonic, and it regularly fails and causes a white light of death. So by replacing that chip and that chip only, we've managed to get this to work again in 1080p, and this console can have a new lease on life. So that's going to be it for this video. Thanks very much for watching. If you have any comments or questions, leave them down in the comment section down below, and I'll do my very best to answer them. If you want to see more repair videos where I repair mainly consoles, but sometimes other things too, be sure to hit the subscribe button and turn on the bell notifications so that you're notified every time that I upload. I am trying really hard to get to 6,000 subs by the end of January, so if you could subscribe, it would really help out the channel a lot. I also have channel members now, where for literally £1.99 a month you can support the channel and get early access to most of my videos. But that's going to be it for this video. Thanks very much for watching, and until next time, see you later. Bye for now.